Are you prepared to be amazed by a plane that doesn't just fly, but reinvents the entire experience of air travel? Imagine soaring faster, farther, and smarter while enjoying comfort and technology that feels straight out of the future. Today, we're diving into the aircraft that promises to change how the world travels forever, revealing innovations in speed, design, and sustainability that will leave you stunned. Let's get started. Lockheed Martin SR-72 is a hypersonic aircraft concept developed by Lockheed Martin's Skunk Works as the intended successor to the legendary SR-71 Blackbird, designed to push the boundaries of high-speed flight for future strategic aviation. It aims to combine extreme velocity, long range, and advanced reconnaissance and strike capability in a single platform, with engineering focused on high-altitude hypersonic performance rather than traditional subsonic or supersonic flight. Unlike most military aircraft, the SR-72 concept is built around a turbine-based combined-cycle propulsion system that merges a conventional turbine engine with a scramjet. At lower speeds, the turbine provides thrust. As the aircraft accelerates past supersonic regimes, the propulsion transitions to the scramjet, enabling potential cruise speeds around Mach 6 or higher, approximately 4,500 miles per hour, nearly twice as fast as the SR-71's top speed. The aircraft is envisioned to operate at altitudes well above 80,000 feet, leveraging thin air and its aerodynamic design to reduce drag and thermal loads during sustained hypersonic flight. Mission concepts for SR-72 extend beyond rapid reconnaissance. Its speed could allow rapid global response, penetrating defended airspace faster than current fighters or drones, and in some studies it has been proposed to carry hypersonic weapons or advanced sensor suites that can gather intelligence or deliver precision effects within minutes across continents. Boom Overture is a next-generation supersonic airliner designed to cut long-haul travel times in half, flying well above the speed of today's commercial jets while prioritizing sustainability and efficiency on global routes. The Overture cruises at Mach 1.7, nearly twice the speed of conventional airliners, allowing city-to-city flights across oceans in a fraction of the usual time. Its premium cabin accommodates 60 to 80 passengers, and it is engineered to operate at altitudes around 60,000 feet, where thinner air boosts speed and fuel efficiency. With a range of roughly 4,250 nautical miles, Overture can complete non-stop transoceanic flights, such as New York to London or Los Angeles to Sydney at supersonic speeds. The airframe uses lightweight carbon composites and advanced aerodynamic shaping, including gull-wing geometry and refined control surfaces, to optimize efficiency while keeping passenger comfort and safety a priority. Sustainability is central to the design. Overture is built to operate on up to 100% sustainable aviation fuel, aiming for net-zero carbon emissions during flight when using SAF. By merging high-speed performance, environmental responsibility, and practical commercial operation, Boom Overture is positioned to revive supersonic passenger travel as a real, accessible option, reshaping how the world connects and making supersonic flight a part of modern aviation once again. X-59 QueSST is an experimental supersonic research aircraft developed by NASA in partnership with Lockheed Martin's Skunk Works to unlock a future where faster-than-sound flight over land is both practical and community-friendly. It is the centerpiece of NASA's low-boom flight demonstrator mission, aimed at solving the century-old challenge of loud sonic booms that previously grounded supersonic travel over populated areas. Instead of producing the thunderous sonic boom that restricted aircraft like the Concorde from flying supersonic across land, the X-59 is shaped and engineered to reshape shockwaves so they do not merge into a loud blast. At about 99.7 feet long with a 29.5-foot wingspan, the aircraft's cockpit sits low and far back due to an elongated nose, which improves supersonic performance but eliminates forward-facing windows. To compensate, X-59 uses a high-resolution external vision system, forward-facing cameras and displays that give the pilot a real-time view outside the aircraft without compromising its aerodynamic shape. Powered by a modified General Electric F414's GE100 engine mounted on the top of the fuselage, the X-59 is designed to cruise at around 925 miles per hour at about 55,000 feet once testing progresses, while dramatically reducing the noise footprint on the ground below. NASA N3X aircraft is a groundbreaking concept for the future of commercial aviation, designed to dramatically improve efficiency, reduce fuel use and noise, and reshape how large airliners operate. At its core is a hybrid wing-body airframe that blends the fuselage and wings into a single lifting surface, drastically improving aerodynamics and enabling a higher lift-to-drag ratio than conventional designs. This layout not only reduces drag, but also opens up far more usable interior space and supports quieter, more efficient flight. What sets the N3X apart is its turbo-electric distributed propulsion system, a fully turbo-electric architecture that uses two turboshaft engines driving superconducting generators mounted at the wingtips. These generators produce electrical power that feeds dozens of electric motors driving small, distributed fans along the rear of the aircraft, allowing the propulsion system to be separated from thrust generation itself. By ingesting and re-energizing boundary layer airflow along the body, this configuration significantly cuts drag and boosts propulsive efficiency. While still firmly in the concept and research phase rather than prototype construction, the NASA N3X stands as a key technology pathfinder for the next generation of electrified long-range airliners. Boom XB-1 is a revolutionary supersonic demonstrator jet built by Boom Supersonic as a 1/3 scale prototype for its future commercial airliner Overture, marking a major milestone in the return of civilian supersonic flight. Powered by three General Electric J85-15 engines producing a combined 12,300 pounds of thrust, the XB-1 measures 62.6 feet in length with a 21-foot wingspan and uses carbon fiber composite construction for a lightweight, aerodynamically optimized structure. Its advanced design also includes digitally optimized aerodynamics and an augmented reality vision system that enhances visibility during takeoff and landing, a necessity given its long nose profile. During its supersonic flights, the XB-1 demonstrated boomless cruise, meaning its shock waves were engineered to not produce an audible sonic boom at ground level, showcasing technologies that could enable future overland supersonic travel if regulations evolve. More than a record-setting prototype, the XB-1 serves as a critical technology pathfinder for the Overture airliner, a 64 to 80-seat supersonic transport planned to cruise around Mach 1.7 while using sustainable aviation fuel, halving typical long-haul flight times such as transoceanic routes. Otto Aerospace Phantom 3500 is a next-generation super mid-size business jet concept set to redefine private aviation by combining ultra-efficient aerodynamics, sustainability, and a next-level passenger experience. Currently in development, its first flight is planned for early 2027, with certification and service entry expected around 2030, making it a glimpse into the future of clean, high-performance aviation. The Phantom 3500's standout feature is its transonic laminar flow design, which smooths airflow over roughly 85 to 90% of the fuselage and wings. This drastically reduces drag compared with conventional mid-sized jets, cutting fuel burn by up to 60% during normal operation. When paired with sustainable aviation fuel, the jet could lower carbon emissions by more than 90%, making it one of the most environmentally responsible business jets ever conceived. Power comes from twin turbofan engines, likely from the Williams FJ44 series, enabling a cruise speed near 590 miles per hour and altitudes around 51,000 feet. Its projected range of approximately 3,500 nautical miles allows non-stop flights between cities such as New York to San Francisco or Miami to London. The cabin is designed to seat up to 9 passengers with generous headroom of about 6 feet 5 inches, combining luxury, space, and comfort for long-range missions, making every flight a seamless blend of performance and refinement. Cirrus Vision Jet SF-50 is the world's first certified single-engine personal jet, redefining what private air travel can be by blending jet-level performance with the simplicity and accessibility of a small aircraft. It is designed to be flown by a single pilot and make regional travel faster, safer, and more efficient for owners, business travelers, and air taxi services. Powered by one Williams International FJ33-5A turbofan engine producing about 1,146 pounds of thrust, the Vision jet achieves a maximum cruise speed of about 311 knots and can fly up to 1,275 nautical miles, making non-stop regional trips like New York to Miami or Los Angeles to Denver possible without refueling. The jet seats up to 7 occupants, 1 pilot plus 6 passengers, with the rear seats often best suited for lighter occupants or children for longer flights. Its pressurized cabin offers panoramic windows, comfortable seating, and modern climate controls, all wrapped in an all-composite fuselage that balances strength and lightweight performance. Designed to operate from short runways typical of regional airports, the Vision jet requires about 2,036 feet for takeoff and 1,628 feet for landing, making it versatile for a wide range of general aviation fields. Its service ceiling is about 31,000 feet, where performance and comfort are optimized. American Liberty Lifter Ekranoplan concept is a next-generation wing and ground effect aircraft concept pursued under the U.S. Defense Advanced Research Projects Agency. This design aims to combine the speed and heavy lift capability of a large transport aircraft with the efficiency of low-altitude flight just above the surface of the water, skimming at heights where aerodynamic ground effect increases lift and reduces drag. Unlike traditional fixed-wing aircraft that require long runways, the Liberty Lifter is intended to take off and land from open water, using its hull and ground effect lift to support extremely large loads without conventional airport infrastructure. Early specifications sought aircraft capable of carrying payloads roughly comparable to a Boeing C-17 Globemaster III transport, which has a typical maximum payload of about 82 tons, while potentially exceeding that in future iterations to meet heavy logistics needs. American Ekranoplan concept aims for unparalleled heavy lift capacity, long-range endurance, and runway independence by harnessing ground effect technology. If realized, it could offer military forces and disaster response agencies a new option for rapid, large-scale transport over ocean and remote coastal regions, blending aircraft speed with seaborne operational flexibility in a way that bridges aviation and maritime logistics. Philippine Mars Flying Boat is the last surviving Martin JRM Mars flying boat, and one of the most iconic giant aircraft ever built, known for its immense size and historic service life. Originally designed and produced for the US Navy toward the end of World War II as a large transport seaplane, it was later converted into a water bomber capable of carrying about 7,200 gallons of water per drop, fighting forest fires for decades along the west coast of North America. Because the aircraft has no landing gear and can only alight on water, crews disassembled it at Lake Pleasant and transported the massive flying boat in sections overland to its permanent home at the Pima Air and Space Museum in Tucson, Arizona. Today, the Philippine Mars stands as a tribute to aviation heritage and engineering marvels of the flying boat era, preserving the story of how these extraordinary aircraft bridged military transport and civilian firefighting roles through much of the 20th century. The Hawaii Mars is one of the largest and most iconic firefighting aircraft in the world, originally built as a Martin JRM Mars flying boat during World War II. Later converted into a water bomber, it can carry over 7,000 gallons of water per drop, scooping directly from the ocean to combat wildfires across islands, coastal regions, and remote terrain. Powered by 4 radial piston engines producing a combined 18,000 horsepower, the Hawaii Mars has a wingspan of 200 feet and a length of 132 feet, giving it the lift and range necessary to operate where conventional firefighting aircraft cannot. Its high payload capacity and long endurance allow rapid, repeated water drops, making it extremely effective in large-scale wildfire containment. The aircraft's ability to scoop water directly from open bodies of water eliminates the need for ground-based refilling, drastically reducing turnaround time during critical firefighting operations. Its robust airframe, stability, and precision controls enable it to navigate low altitudes safely over rugged landscapes, while the crew can execute targeted drops to protect communities and natural resources. Chinook Helicopter, specifically the Boeing CH-47 variant, is a heavy-lift twin-rotor helicopter widely regarded as one of the most capable aerial firefighting platforms in operation today. Its tandem rotor configuration provides exceptional stability and lift, allowing it to carry up to 10,000 liters or 2,600 gallons of water or fire retardant in internal tanks or external Bambi buckets, delivering rapid and precise drops in wildfire zones. Powered by two turboshaft engines producing approximately 4,750 shaft horsepower each, the Chinook can reach speeds of 170 knots and operate at altitudes up to 20,000 feet, giving it access to rugged terrain and wildfire regions unreachable by ground crews. Its agility and stability allow it to hover accurately during tank refills or drops, while advanced avionics support navigation in smoke, high winds, and challenging mountainous terrain. Refilling operations are extremely fast, often taking less than a minute when using hydrants, lakes, or portable water sources, enabling continuous firefighting sorties. The helicopter's capacity, speed, and reliability make it indispensable for large-scale wildfire response, protecting forests, infrastructure, and communities worldwide. Equipped with robust redundant systems for safety, including dual engines, hydraulic backups, and reinforced airframes, the Chinook remains a workhorse in both firefighting and rescue missions, demonstrating why it has become a cornerstone of modern aerial emergency operations. As we land, one thing is certain: this plane isn't just a concept, it's a glimpse into how travel will evolve for everyone. From faster journeys to greener skies and smarter technology, the future of aviation is taking off before our eyes. If this video amazed you, make sure to hit like, subscribe for more mind-blowing innovations, and drop a comment telling us which feature impressed you the most. The skies of tomorrow are arriving faster than ever, and you don't want to miss a single flight.